Okay, so I'm Stefan. I'm from 3Screen Solutions. Oh, that doesn't. Either way. So please disregard the font of the presentation. It's supposed to look a little bit nicer. I want to explain you a little bit about our article we wrote on microservice-based, container-based microservices in the cloud. I will not go too much into the details of each of the individual topics because containers, microservices, and also Docker itself could be probably 1 hour session on its own. But I want to explain to you a little bit what we did, why we did it, and where we ended up now. And before that, some short background on our company to understand also what we worked on and what the use case is for us. So we are focusing on VOD, IPTV, and OTT. So we have customers which are content providers, broadcasters, channels, which want to stream media live or video on demand to customers on multi-screen devices. So this means usually like Netflix and others, they have different front ends, iPhone, Android, web, consoles where the users want to consume the content, and we provide applications and also backend solutions for this. We are in different countries. Romania, actually Mauritius is I think our biggest dependency, where most of our development work is done. We have Moldova, Ukraine, Germany, Switzerland, and also USA, mostly front-end work. Okay, who made this article? These 3 guys, Jolo, Boti, and me. This time there's also in the audience. The knowledge is split, not 30-30-30. I would say the other 2 did the work, I do presenting. So if you have questions, you can later on head over to them. So why do we think it's interesting? I put on the right side or the left side, wherever you stand, I've put on this graph about adaptation and usage of new technologies or technologies in general. And as with every hype technology, there's the point where you think it's cool, you can do everything you want, and you know how to do it. And probably this is the point where we decided to use it for our new product development in our company. And then pretty much we hit the bump and we figured out that we are not there yet. And then yesterday I said I'm not sure how much to the right, to the mastery achieved, we actually moved. But since today my boss is in the audience and we spent quite some resources, I would say we are now total masters of this. Okay, why do we need it? I think it's pretty obvious, but just to explain why we do microservices at all. So our customers usually have 4 to 5, even more backends, and they are from different years, legacy backends. Some use XML, some use REST. It's very indifferent. And on the other hand, we have to do a lot of clients. And like I said, multi-screen means you need to cover every device a consumer potentially has, because otherwise you lose money. So this means we are talking about 10, 15 different clients, best case. And this multiplies amount of clients times backends. You would have to do a lot of work. Yeah? Now you need to imagine that at one point maybe one of those customers decides to switch the billing system, to switch the CRM, to maybe exchange the whole backend, which means you have to do the whole backend integration again 15 times. So we decided, as others before us, let's put something in between. We call it a mediation layer because what it doesn't really do a lot of logic. It just mediates APIs, data, and flows from A to B, and make sure that we always get the right format as we expected. But of course, we are talking about VOD, live TV. This means potentially we have a lot of customers at the same time using it, so we need to be able to scale. What we wanted to achieve in total, we wanted to deploy anywhere. One of the reasons we have seen in the first presentation about Google, the pricing models, when we're talking about cloud, pricing is always a topic, and I think a few days ago there was, for example, a small uproar in the internet when people which used Firebase suddenly had bill increases by a few thousand % because the billing model changed. So it's always important that you are able to react on this. And we wanted not to have any ties to any cloud provider. Also, sometimes our customers have their own environments where you need to deploy, so you can't just say let's go with AWS. We wanted to update and replace whenever required, like I said, because this is happening in our world. Backends change. We did not want to tie to one technology for all time, because when we started, and even now, it might still be that Node.js, which we use right now, is not always the best choice. So we want to be open for this. Like anybody, we want to maintain it in the smallest possible teams per service, and we need to scale with the growth of our customers, because Since this backend we are building is for an off-the-shelf solution, typically the customers start with very low usage numbers and it scales up. But on the other hand, infrastructure and hosting is not really a position in their books where they want to spend a lot of money and a lot of time. So it needs to work as simple as possible. Okay, how did we get there? The most obvious thing, we did a lot of trial and error, and we're still not done with this completely. At the beginning, we pretty fast decided to go with Kubernetes because we had some experience on a previous project. And when we, I think, had the point that we moved from a pure development to a staging or production environment, things were not looking so bright anymore, so we looked into other solutions. We, at the beginning with development, worked with Ranger, also had some drawbacks here. The same in the structure of our application. So I wrote here that we have a small generator script which has a base skeleton for each of our services we built. I think it also took some time to get this one right. A lot of hiccups had with this Docker container building. The build process here was not so easy. And what we needed to achieve, because we are talking about microservices with maybe at the moment 8 to 10, but they will grow to maybe 20 to 30 per customer, which means we have 20 services on probably 3 environments: development, staging, production. Multiplied again by the amount of our customers means that we have a lot of monitoring to do to know that what we deployed actually works, so that we don't get surprise calls late at night. So this was also something very focused. We ended up with Docker as the container platform, Kubernetes as the orchestration system for this. We decided Google Cloud for the hosting, not because we are experts on this, but we started with AWS because it was the obvious choice. And then at one point, Google just had the better numbers for the use cases we had, so we can save some money at the moment with Google. Not sure if this will always be the case, but right now, and the good integration for Kubernetes was a plus. We use Nginx for the caching and routing of our APIs. Everything behind the Google Cloud load balancer, then obviously, like I said, we chose Node.js as the development language at the moment. All our monitoring, application logging, service logging is done with ELK, so we use Elastic, Logstash, Kibana. We use Beats to send our log files to the system. I would say it's not so advanced as what we have seen in the morning, not in the morning, in the beginning of the session, but also we are not data experts, and this is still, so at the moment we collect a lot of things, and now we are working also on how to get it out again in the right way. And we use a Nexus as a private registry for our NPMs and our Docker containers. For those who are maybe not so familiar yet with the latest hype, so how did we move from our old setup, from virtual machines or classic hosting to the right, to the Docker-based infrastructure? In the end, if you look on the left, what we had, or still have in some cases, we have a hypervisor which is working on some infrastructure, it's Veeam or something else, and then we deployed always virtual machines with a guest OS, which contained full applications or parts of applications, and then if we wanted to have redundancy or scaling, we duplicated it, we added another one next to it. And if then we needed to do updates, we updated the application, but not the whole system. And if we wanted to update the whole system, usually our IT had to make a snapshot, freeze it, make an update, and then we had images of a few gigabytes, which you also cannot transfer so easy. So now with Docker containers, the whole trick is that you deploy each service individually, and instead of using a full virtualized environment, you just use, let's say, a package which contains all the executables from the operating system and from the application which you need, which instead of having its own complete resources, it just shares the resources with the host OS through the Docker engine. And then we deploy each service individually with a very small OS. Right now we are using Alpine Linux for this, so that instead of having machines which are very large, which consume a lot of resources and which need to be maintained individually, we just have these small parts which we can add and replace whenever we want them. A bit closer, with an example from 2 services we are using. For example, we have an authentication service which surprisingly does authentication, and we have an asset store which handles metadata. So these are deployed then individually in the darker gray boxes. Each of them contains everything Node.js requires to run, and we're using PM2 as a process manager right now to keep them alive. And then we have the base image and the Docker file, which together then make our deployment bundle. When we started, it was the classic setup. We had Docker on our OS, and then we transferred all this to the Google Cloud Engine to save some efforts for ourselves. Very simplified and with the most beautiful font you've ever seen. This looks now roughly like this. On the left, as I said, we have a Google Cloud Load Balancer which handles all the traffic and the SSL termination. And then we have created different service nodes which contain all our services, which then, based on the Cloud Engine, get assigned to different pods to run actually the Docker containers based on the load. And the nice thing which Kubernetes does for us is that it handles all the scaling. So this means if Google Cloud detects a lot of traffic for a certain service and needs more resources, it just decides on its own, okay, I need to create a few new pods, or I even need to replicate the service node for that. A screenshot how this looks from the Kubernetes admin interface, so just that you see how we now also at with one view can monitor all our services. You see here the CPU consumption, the uptime, memory consumption, so it's also very easy now for us to monitor this all at once. I mentioned that we use Logstash and Kibana, so not probably because it's so readable, but just to give you an idea, we get tons of events from everything our services and our hosts and our containers do. They are structured and labeled with environment, with service name, so that we can easily find out which service is doing what at the same time. And we also are able to correlate, for example, the performance of our API with the logging from our applications, because we do all this in the same environment. So we also to figure out at one point maybe why usage drops while API responses increase. The CI pipeline is actually very simple. We do the builds with GitLab CI, so we build our Docker images and we update them to our own registry, which we do with Nexus. And then on the environment, meaning Google Cloud in this case, or our local environments, we just again pull the images and let the orchestration do the work. Some snippets from our GitLab CI file, which I now put in just to give a quick glance at this. In the end, the relevant parts look rather simple, but I think it took quite some time to get the setup done right, and there were a lot of small issues. We try to do everything with environment variables so that we can use exactly the same flow for every service, and still when we do the builds, we know which version of which service has been deployed. And also we are creating API docs, as any good developer does. So all this is handled automatically from the CI flow. So before we start with all this, we set all this up. We also have a small webhook to notify us in Teams when something happens. And then after 50 or 60 other files of installing NPMs, deleting directories and so on, actually after we did it, it's very simple. We just execute a few small tests to make sure that what we have just built is actually running. Then before that, actually, we build the Docker image with all the arguments we have based on the environment variables before, and afterwards we just push it to our registry with the latest 2 commands, and then it's available for us to deploy it. What did we learn? One of the big points was that it's not just a development job, something we underestimated at the beginning. Now, meanwhile, we have Bodhi, who is actually not developing anything anymore on this, but just making sure that the infrastructure is set up right and works right, and is digging into this. We took time to find the best tools and setup. I would say 1 year for now, and I'm not sure if we still have everything because tools come and go. A new stack. Back then when we started, it was relatively new, comes with a lot of risks because you get breaking updates, for example, for admin interfaces, interfaces change. At one point we thought we are really clever and update Elastic to 5. something because it came out with a new feature. This was one of the less bright ideas we had because the new features were nice, but they didn't work with anything else. The same as the fast releases. Since we now have this fantastic CI flow, of course everybody expects us to quickly shoot out updates when something happens. But if you do this together with the next point and you don't have a proper release management, you at one point are pretty much lost. What did you deploy where and what is working? What we need to do, we need to solve or finalize inter-service communication from our microservices. We still need to optimize the infrastructure we have because we started as noobs and now are a few steps away, but we still can save a lot of money and find better components. This persistence in Kubernetes setup, this was an issue with Elastic because we needed to write a lot of things and you can't just scale this up, but there is also now a change with this where we have now new replica sets which are actually stateful, and I think this solves some of these topics. Caching needs to be improved. Right now this is all done by Nginx and it works, but we can also make this a bit more advanced with other caching solutions. We want to switch to fully automated building and deployment at one point, so that this is also taking less from our time to actually do this. That's it. Do you have questions? Yes?
Can you go back to the slide of old versus new, please? It's not clear to me why on the left-hand side you had app A, app B, and C, and right, service 1, service 2, service.
Yeah, so the
the
naming maybe, so you could also say app A, second version of app A. Yeah. So it's the point is on the difference between the left and the right is when back then we had the backend, we deployed it as one application and all the services were part of this one application, monolithic application. And then, maybe it should have been AAA, so then you just duplicate it, we have redundancy in scaling. While on the right side, then you would just replicate the services by Kubernetes. That's the idea.
Yeah,
yeah, if you want the font, it's Times New Roman, if you want to use it. Okay, that's it.
Thank you, Stefan.